কোনো কারণে বন্ধ হয়ে গেছিল। Okay. So let me just tell you that in IP addressing we are having 5 classes A, B, C, D. আমি একটু ABCD করতে করতে ABCD E F অব্দি চলে গেছিলাম। তো 5টা ক্লাসের মধ্যে A, B, C এই তিনটে ইউজ হয় ইউনিকাস্টিং এর জন্য। D is used for multicasting. It's a multicast network, and E is reserved. Okay. Till I have not find out any addresses which is reserved for a purpose, but still people say government, DRDO, these that. But I've never used any class E address as such. Okay. But this is reserved category addresses. So if you look into the IP addresses, IPv4 addresses, there are 3 categories of addressing. I can say that 3 categories mean 3 types of addresses. So anyway, the communication system, okay, has unicast any. There are 4 types of communications. Okay, in terms of communication methods are there as per the users and cardinality is there, like unicast, okay, anycast, multicast, and broadcast. So broadcast was a very huge problem. যেমন নেতারা ভাষণ দেয়, আমি এবার ভোটে এই করব ওই করব, no one he is least bothered who is listening, who is not listening. So radio, FM channel, any such channels are basically using broadcast. Still we are having Doordarshan is a broadcast system. Free channels are free to air channels are broadcast systems. So other than that, if you are talking about any Star and all, they started communicating with after the IP system came, they started using multicast. Why multicast? They can actually understand who are the users. So I'm communicating to 100, or I should know who are my subscribers. So accordingly, I'm not talking about old day cable TV. Now latest technology, they started moving into, most of the channels started moving into multicast system, and IP address means IPTV and all those things came. So what is unicast? All of you know. For example, 2 devices are talking with each other. It is a unicast. What is anycast? Can anyone tell me? What is anycast? Okay. Anyone who know, or anyone who can try? One to nearest, that little bit, if you can elaborate. No, IPv4 also. They have IPv6 came with a default feature of anycasting, but still. কারোর একটা মাইক অন হয়ে আছে। হ্যাঁ, একটু মাইকটা বন্ধ করলে ভালো। ফিডব্যাক আসছে, একটু মিউট করে দিন। কি কার আছে? ডেইজি ম্যাম, ডেইজি ম্যাম। ডেইজি ম্যাম, প্লিজ mute yourself so that I can actually. হ্যাঁ, ঠিক আছে, থ্যাংক ইউ। সো এনিকাস্ট সবাই গুগল ইউজ করেন তো? গুগল পিং করলাম। আমি 3টে পিং করেছি। I made 3 ping. কিছু স্যার কি ভালো। আচ্ছা, আমরা প্রথম পিংটা করলাম www.google.com. Anyone who doesn't understand Bengali? Okay. Oh, okay. Sorry. I'll start coming. You are from Kerala. Okay. No, I don't know Malayali. I can understand a little bit of Tamil. Yeah. Tamil, தெரியும். Malayalam, I don't understand. I studied in Chennai, and that is the reason I understand that language. It was very hard to understand your language, ma'am. So, sorry, I cannot communicate with you in your language. But I understand your pain because I started speaking in Bengali. So, I'll now communicate in English. So, I have done ping www.google.co.in, ping www.google.com, and ping Gmail. Means, see, can anyone tell me that? See, you just go and see the IP address 142 dot 142.250 dot 183 dot 1 131. Other one is 132, and another one is 145. So, what do I understand by this? Can anyone tell me? So you can understand that there is a pool of servering. Means in the network there is a pool of server. One is 129. Morning I was pinging, it was 129. So you got someone which is 129, 131, 132, 145. So same Google server, I'm just means if you are pinging, you might get 129. So why the pinging is happening from different devices? Can anyone tell me? The problem is not problem. The thing, what it happens when you are actually asking the server to respond, the request goes in the form of multicast. It goes to the not one, to the all possible servers which is hosting Google. The one who respond to your request will start communicating with you. So the request goes in the form of multicast, and then the response comes in the form of unicast, and then you start communicating. So what will happen if the communication goes off with that server? Immediately someone will take care. IPv6 এর local unicast করতে গেলে what we do basically, we are having a mobile phone, we tested initial days, toothbrush, washing machine, AC, every device is mobile phone, then you are having a laptop, every devices you configure with Anycast IPv6 local Anycast, and you start pinging. All the devices is getting messages. So the one which you pick up the first will do the communication. So very clear, this is Anycast. You send a request in the form of multicast, and the response comes from Anycast means any one of the device which you hold. It's not first come first serve actually. It is the who is responding, who is reachable. So you are having multiple devices which configured with, for example, you are so someone is Ornob, which is having ornob.com. So ornob.com is hosted in many places. I send a request goes to not one in all ornob.com. Not its unicast address. See, this server, no, this is the after that response comes, it is used as a unicast. Means it is used as a unicast. It looks like a unicast. No, you type, sir, ping www.google.co.in. I just typed not the IP address. If I ping IP address specifically, it is only unicast. I didn't ping IP. I ping the server. I am ping www.ornob.com. DNS server will not resolve. The DNS resolver in Anycast work in a different way. Because you ping multiple time for multiple device, you get a different IP address. No, every server in IPv4, every server configured with IPv6 comes with a default Anycast that you have to go and router and activate that. That's I'm not talking about. The server, for example, someone has purchased ornob.com and he has decided that my server will be a Anycasting, do Anycasting. So I'm having, I can take Citrix, I can take different kinds of server, and I am mapping 4 5 servers. It is not about domain name mapping. It's not NS record 1, NS record 2, NS record 3. It is not about that. Okay. It is about the mapping. All the NS records are mapped in multiple places. So what is happening? What is happening? It is a single server, but mapped in multiple places. No, it's not load balancing. It is not load balancing. Anycast doesn't take care of load balancing. For example, you get 100 requests and only one server is responding. Rest all are sitting idle because they might not be reachable. It's not load balancing. It's a reachability issue. For example, if I trace the packet, I can only see that one server is good and he is responding, or that particular server is responding, and that actually server has to take care of when they configure. It is going to other servers, but the problem is that see, everyone is getting response, but the one who is actually proactive, he is actually processing the request. It happens in case of DHCP server. Na? You send a request, but those who is responding and start communicating. See, it's all who is responding fast. Hmm. Others are also there in the queue. In Anycast, also there in the queue. It's depend on not only TTL, sir, other factors also there. You see, okay, I don't want to discuss. You see there are other factors also. In if you go and see the IPv4 addressing, okay, TTL is just a communication. Means once the communication established, it will just tell you the time to leave. The packet time to leave is different. Okay, there is additional extra bit available. If you look into the IP header, flow control, before that there are additional bits are there. That additional bit you have to set flags. So the guy who has, means the server who has responded, he is sending message to others. No, I am responding. That's the reason it is Anycast. So you send a request, 10 people got the information. So one respond and say, hey, I'm actually interacting. So if I fail, automatic others will know, and the best possible one who will be started, interacting with me. So it is a huge configuration. There are tools by which you need to configure the Anycast. Huh? See, in Anycast communication, what is happening? Anycast communication, what is happening? For example, madam, you are having 4 servers. So once I try to reach, all the 4 servers will get my request. So out of the 4, who is responding, he will tell I am responding, and rest all will be there in the standby. So if first server stop responding, any case, okay. So there is always beckoning is there. So, or it's, I will not say beckoning. Beckoning is in Wi-Fi. So always there is a communication system which is keep on telling others, okay, I am responding. The first server stop responding, the second base server will start taking. This is Anycasting. In Unicast, what happens? The communication goes off. No one is there to help you out. Backup. In Unicast, if you are pinging, and if the communication goes off, what will happen? The communication complete, means communication will no further available. Anycast will not never let you go. Anycast will do, okay, fine, I am responding. My backup server, I stop responding. My backup server will start responding. Yes, sir. আমি তো ব্যাকআপ রাখছি বলেই Anycast. If I'm having more than one server or more than one device which is having that which is part of the communication system. For example, if I'm having 5 servers, I think minimum is 3 or 4. You need to have 3 or 4 servers to start at least a Anycast system. I forgot. I have to check and get back to. But thing is that using that only you will be able to do the Anycasting. Response means I am sending a packet. Okay, the one who got the means process the request first. In DHCP, what is happening now? Who is getting the request first? It is only the person who is getting the request first will start, yeah, start responding and tell others, hey, I am doing. ঠিক আছে? হ্যাঁ। Yeah, হ্যাঁ, হ্যাঁ। Yes, yes, yes. Hmm. It's not client. It's not means client. It's a server. No, no. For example, it's only happen in the environment of not client to client communication. It's a client server communication. So client is sending a request, na? I have 4 servers. How you can have sir multiple devices with same IP address? I can do. IPv6 is totally different concept. I'm talking about IPv4 was made to use Anycast. That is the reason they made this. IPv6 come with a Anycast address. Means IPv6 address. They have, this is my Anycast address, this is my unicast address, this is my multicast address. So many things comes. You know, if he no IPv6 is not there, but categorization is there. Means if you go and type, okay. No, if you go and type in the device, you write this is IPv4, IPv6 unicast routing, IPv6 anycast routing, IPv6 multicast routing. So even if you are doing multicast routing, you can still use starting with 2 or 3. No dedicated space for any kind of communication. Means, for example, if I am communicating, there is no space that they have not yet decided, because still it is not in a mature state. I'm telling you IPv6, but later on they have to do it, because now they are also not very clear about subnetting. They're using UI64 method. UI64 method is an automatic method. It is telling that okay, 64 bit is my network portion, 64 bit is host portion, and by default you go with this. Not in when it's not even matured. No, it's just only start with 2 numbers. Anything start with 2 or 3 worldwide. This only 2. Uh, that's global. But rest are local. Na, you can do anything. Like yesterday, I was showing it to you. Once I ping my uh, IP config. Here we are using 50. So it's not that you cannot use 50. You can use 50 anyway. My discussion is going to a different angle. So Anycast is basically where it's a one to many request, and then it's a one to one communication, but rest will also means assure you that there will be communication. So this is the basic concept of Anycast. Request one to many. I'm not telling this address is Anycast address. I'm telling Google is the Anycast server. That is configured. That server is configured with IP. No, but that will not actually start with, no, that will not lead to this kind of issue. Na? Once you ping Google, it is going to different server. See, I showed you in fraction of a time. Yes, not 4, 16. 4, huh? Huh. Individual record is present because see this no this is IPv4. IPv4 doesn't come with any cast feature, right? No, I am telling that server is working like Anycast. See, Anycast communication system is working in this particular fashion where Google server made of. It's an example. Not actually. It's a type of Anycast communication. It's not a it's not a Anycast communication. I'm telling IPv4 doesn't happens to be Anycast, but it is replicated Anycast. Means Anycast is happening. If the first server stops now 191 or 1, if this first server stops responding, immediately this server will start responding. Because happens in clustering, but they have incorporated Anycast kind of system. No, clustering. No, but একটু বেশি হয়ে যাচ্ছে clustering. No, clustering will never happen that the ping will happen from all. Clustering will respond from one server, right? Down, but here no server is down. All the 100 servers respond. If I have a 3 physical server and I have created no, why I am telling you, if you ping google.com, every time you will get a different IP address. Why? If I am pinging google.com or google.co, there will be multiple clusters over there. But cluster is down. But why no, nothing is down. No, not always. Check it out. But multiple pieces. Here the server is already stuck. Means every time it will take that IP. After 2-3 hours, if I come back, it will change because I have tested. The server can round or anything else. That's why it is different IP. This is not a DNS server. This is a report defined. Same. No, if you are said now, my concept is why I am telling you that is a replication of Anycasting, because at the same time, if 100 people are pinging a single server, why the IP address are changing? Single server, google.co.in or google.com. There are multiple servers. Multiple locations. So you have a cluster. So I have a specific data center Australia there will be a server, England there will be a server. If my Asia see, you cannot actually say that these 4 servers are located in which location. No, not cloud actually. They are having that. But it is not in India actually. Maybe not. But we are nearest to me. That is nearest to me. So no, why I am trying to tell you is that this is the types of Anycast communication. I'm not telling this is a Anycast server. I'm telling this is the way Anycast communication works. Actually, my question is this: how can I know that particular IP? It's not an Anycast IP. I'm telling that this is the way of Anycasting. This is a concept of Anycast. I didn't say that this is Anycast. This is a Anycast IP. I didn't say it's a Anycast IP. I'm telling it's a Unicast IP. আমি বললাম Anycast এইভাবে কাজ করে। আপনি অন্য ডাইরেকশন যাচ্ছেন। আমি বলছি Anycast এইভাবে কাজ করে। যে when you sending a request, Google is responding from different servers every time. Why? Because you are talking about cluster. In cluster also, it is responding from different IP address. For example, google.co.in mapped with many DNS record and many IP address. So it is something like a replication of Anycast. I'm not telling this is Anycast. IPv4 doesn't support Anycast. IPv4 is not supporting Anycast. But Anycast communication is happening in this particular way. I'm telling you. But this is the way I can tell that Anycast works. If I wanted to check type of Anycast, that's why I'm telling you. Same IP in different server. That is IPv6. But I'm telling that IPv4 has been used in such a way that it is replicated. It is a replication. আমি বলছি এইভাবে IP Anycastটা কাজ করে, but not this is a Anycast server. You are telling Anycasting, এটা Anycasting না, Anycasting টা এইভাবে কাজ করে. So you misunderstood the entire thing. এটা আমি এক্সাম্পল দিলাম বুঝতে। আমি বললাম এই 4 রকম কাস্টিং এ Anycastingটা এইভাবে কাজ করে। না মানে হ্যাঁ আমি বুঝতে পেরেছি, আমি ডাইরেকশনটা স্যার ক্লাস্টার বলেছি, আমি ক্লাস্টার কনসেপ্ট এখানে ডিসকাসই করতে চাইছিলাম। I'm just trying to tell you that how Anycast communication really look like, and that is why when you ping any device or ping any, for example, I am pinging you, and when you are replying back, you are replying every time for different devices. Okay, in local area we implement using IPv6, but in Google this kind of server works in similar fashion how Anycast works. I'm trying to tell you the Anycast method. Sender will send a request that will go in the form of multicast. Converting, you are targeting a device, or you are targeting someone. Okay, when the request goes from client to server, it is a request in the form of multicast. No, it's a Anycast address. It's Anycast address. No, destination is a Anycast address, but it will go to many locations. Anycasting means this is a sender. No, your question is right. This is a sender, this is a destination. If I am holding any Anycast address, I am having device 1, device 2, device 3, device 4. So I am having Anycasting. Anycasting means this D1, D2, D3, D4 all are replicated, because when you are sending, for example, okay, you are sending 2001 : FE : 001. So when I'm sending the request to this is going in the form of, if it is configured with a Anycast communication, this is going to D1, D2, D3, D4 simultaneously, the request. Okay. So when I'm pinging this, it will go to 4. So, No. Out of this 4, D1, D2, D3, D4, if D1 started responding, it will look like I'm not. D4 I'm connected. Can be in different location, but configured with. But they are having their advantage now. Anycast. That's why who is using Anycast? Can anyone tell me? See, sir, the problem is, you need to understand the application first. Unicast is a very basic communication, right? I'm talking to you, are talking to me. But I wanted to address many people. So, for example, I wanted to have a live session with all faculty members, and you are having 4 devices here. I started pinging you. Your first device responded, and I'm connected. And somewhat that device goes down. Okay. Another server will immediately take charge and start doing it. There is the advantage. You have to understand the application where I can have the advantage of Anycast. The communication came with some advantages. The advantages is, if D1 goes down, because see, it looks like a request goes in a form of multicast, and when the communication start, it looks like a unicast. This is the concept of Anycast. But the thing is that if in any unicast communication, if the first server goes down, the second, third, fourth will never be there in the system. But in Anycast, there is there. You can say, sir, I am having a traffic. Now, if you are talking about traffic, in 1998 we had a dial-up connection, right? So someone have used. So post 2010, have you ever seen anyone using dial-up connection? No. So what is the minimum communication if you go 2 Gbps? Now I am having in my home 100 Mbps connection. Okay. And if you look into my entire flat, there are 100 into 100. So that much bandwidth my local service provider is providing, right? Or if you look into any community, more than 1 lakh subscribers are there of Jio who is getting this 100 Mbps connection. So see the traffic in the network. So do you really think I am bothered about the communication traffic, or I am bothered about that my connection should not get lost? That's why Anycast came into picture, right? And if I am doing a multicast, there are a lot of disadvantages. I am talking to every time 10 people. Why I should connect it to 10 people? Na? So instead of that, whomever I am required, I will be able to connect, or I will be able to communicate with him or her. And that is the reason Anycast came. So there is a reason why broadcast was down, because broadcasting is creating a lot of problem, DDoS attack, like ping of data attacks. And that's why IPv6 came. They said no, I will not take broadcast into consideration. I will never come with a broadcast communication. So I'll come with unicast. Multicast is there, and I will introduce a new concept, unicast. So to tell unicast, I was just telling you this, that this works like a unicast. Whenever you are pinging Google, it is responding from different servers. That's why I'm trying to tell. It's not that this is a unicast. Okay, this can be clustered. There are other, how Citrix server works. I need to take a full class about Citrix server. Citrix server is working in this kind of, Google Citrix is an application which works in this kind of. It's not a pure cluster. This is having virtualization and other things. I'm not getting into such things. So don't. So I take 10 minutes. There are different concepts. So I'm just trying to tell you about the communication system and unicast, anycast, multicast, and broadcast. So anyway, those could not connect with me in last 10 minutes. I'm sorry. So I'm coming back to that. So in IPv6 we are having unicast, anycast, and multicast. And in IPv4 we had unicast, multicast, and broadcast. So coming back to the basic things what I was talking about, in IPv4 I'm having broadcast. So what is my broadcast address? You need to understand. Broadcast address is every network, the last IP address is the broadcast address. Okay. So if you talk about the addressing, there are three types of addressing out there. One is called public, one is called private, one is called reserved. And this reserved are basically reserved for several purposes. There's several purposes. In class A, if I talk about private addresses, so class A, what is the range? All of you know, it is 0 to 127. I am not getting into that how to calculate, because if the first bit set to 0, okay, then it is 0 to 127. It is 0, 1, 0, then 1, 1, 0, 1, 1, 1, 0. You all teach computer networks. I'm not going to tell you. Out of that 0 to 127, 0 is basically global DHCP client. So 0 you cannot use, right? So starting with 0 we never use. So we start something from 1 to 126, because 127 is again used for loopback addressing, and here the starting with 10 is used as a private IP. So we all know, and there is something that is called default subnet mask. Default subnet mask is 255.0.0.0. So this is my default subnet mask. We call it as default subnet mask. So what is subnet mask? You know that if we, there are few things in the network, so I'm not getting into that. First is called network address. Okay. Then we are having a valid range of IP address. I'm just going this with a quick, discussion. The value network address and valid range of IP address, and last address is basically called broadcast address. Okay. So if I take 10.0.0.0/8, we call it as a CIDR notation, right? We call it as a CIDR notation. It's called classless inter-domain routing, CIDR notation. So if I see 10.0.0.0, this is basically called, I'm writing in a network address. Okay. So what is the valid first address? 10.1, and valid last address is 255.255.254, and this is my valid range, and valid range, this is my broadcast address. We call it as a broadcast address. Okay. So why it is called valid range? BA means broadcast address. Why it is called valid range? Because from 1 to 254 I can use. So how many number of valid IP addresses are there? It is 24 bit, 2 to the power 24 bit minus 1, 2 to the power 24 minus 1. So this is all about my, okay, and subnet mask is 255. I have already written that this is my subnet mask. We call it as a default subnet mask. Someone is writing DSM, default subnet mask. So once we talk about class B, again class B range start from 128 to 191, because 192 is class B. Okay, out of 128 to 191, okay, 172.16 is a reserve. Sorry, 192, 172.16 is a private address. So there is one address which is starting with 161, 169 dot. It is called APIPA, automatic, private IP address assign. It is assigning IP address. So APIPA is automatic private IP address allocation or something like that. So it is called APIPA. APIPA is basically in a network. If you don't have a DHCP server, still you can communicate. Okay, what will happen? You switch on all the machine. They will pick up a by default APIPA address and start communicating. It will work completely. It will work. So there is no problem at all. You don't require a DHCP server. So people always say that with APIPA UI64 that is mapped. Actually, no, that's a SLAS, stateless automatic address configuration. So I will come to that later. Anyway. Hmm. Hmm.
Can I configure NAT on basis of
No, কি করা হবে? APIPA read করতে পারবে না নাকি? See, you cannot configure APIPA because that's a reserved address, na?
that means I cannot do anything without sharing.
No, you cannot. You cannot. No. You can only. For example, there are 30 computers. You don't have a server. You switch it on. You start communicating. It's a local. It's a local network.
Local network.
But when you no, you cannot configure even gateway also. So if you cannot configure gateway, then how you communicate outside? Netting is a different concept. You don't have even configure a gateway. You have to, whenever you are configuring a network, you have to have a gateway. There are three things: IP address, subnet mask, and default gateway. We call it as default gateway. And if you don't have any network which is having a default gateway or gateway, then the network is a means just a private network. Means it cannot communicate further. এই ঘরটা গোল হয়ে গেল আর দরজা নেই, কি হবে? What will happen to this room? It will never come out. You never know now which is the corner of this room, right? So it's something like you don't have a gateway. And APIPA is just for basic IP fail and you start communicating. Well, file folder share you can do and other things, but it will not communicate further. That's why it has been made reserved, because very emergency purpose you are getting IP address, you don't require a minimum network service. Yes, it's just a communication. Basic communication can happen. Ping can happen. Basic communication happen. File sharing can happen. No IP conflict will be there because
Send the broadcast to AIP. So each machine should have that whose machine it's which particular IP.
That's there, yeah. But you cannot do any further communication. That's it. It just stuck there.
Another thing is that every 5 minutes interval, if I'm not wrong, APIPA checks whether the DHCP server is available or not.
Yeah, every 5 minutes or I don't know. I have to check.
5 minutes.
I heard 180. 180 means 3 minutes. Okay, I have to check.
In Microsoft Office,
I have to check means I'm not sure. So I'm not arguing anything because I'm not sure, but might be 5 minutes or 180. 180 is a very standard time frame for any network communication. 180 seconds. Huh?
180 seconds.
Yeah. But are you getting APIPA time in Google? If it is a 5 minutes, that's said I'm taking it anyway. Let's not waste much time. Okay. Huh. Zero is reserved for zero is a global DHCP client. If your machine is set to zero, it is not part of any class. Global DHCP client means, for example, just a minute. There is a question. Good question. So 5 minutes. Okay. No, that's why nice. That's it. Rightly. So sorry. See, this is my DHCP server, for example. And I just wanted to show it to you little detail. DHCP server. So this is my computer, and I am sending a DHCP request, right? So when I'm sending a DHCP request, you see what is my source IP? 0.0.0.0, which says I don't have IP address. I'm doing a MAC broadcast, and my IP address is not set. Means it's a global DHCP client 0.0.0.0. So that means I can take class A address, class B address, class C address, any address, okay, which you will provide. So it's not that 0 is not part of class A, rather it is reserved for global DHCP client. So when my machine is set to 0.0.0.0, that means I am ready to accept class A address, class B address, class C address, depending on my DHCP server. So when it goes to this server, let's see how server reacts. Server, okay, when it comes to the server, what server is reacting is, server is basically finding out, okay, there is ICMP packet and finding out that, okay, that my scope is starting from 0, so it find out the MAC address. So initially how DHCP works, you have source IP which is missing actually, source IP is missing, that means 0.0.0.0. Destination IP is again missing. Okay, this is the DHCP server which is not yet, okay, discovered. It is broadcast. It is broadcasting. Yeah, it's broadcasting. And source MAC is basically saying 0.0.0.0 and okay, destination is 255.255.255.0. Global broadcast. And source MAC is your MAC address and it is SFFF global. It's all set to and all set to one. That is global broadcast. So what happens? Whoever is the DHCP server will understand this pattern. The source IP is 0, destination IP is global 255. So that means 0, 0, 0, 0, 0 to 255 means any range of IP. So this is a global DHCP client and it is a global broadcast address. You can say this is a global broadcast address 255.255. Local, it can be, yeah. It's a within a not subnet. It is within the same domain. We can say that domain. Within a domain, it will do a broadcast. But why I'm telling you, because this broadcast address is not defined. It will go anywhere where it will be. মানে জলটাকে ছেড়ে দিলে যত দূর অবধি যেতে পারে তত দূর অবধি wherever it can go. No, router can take forward also. 455 forwarded by router. If we configure otherwise no. If my router is only understand that it has to go to a DHCP server, this packet will go. You have to give IP helper address, but not that will act as unique from router to DHCP. Router to DHCP, and it will forward that request uniquest. Yes, but what is inside the uniquest? It's a broadcast request, right? Who is resolving the request? See, you are having DHCP client and you are having DHCP server and you are having DHCP resolver, right? If I am not wrong, there is something that is called DHCP resolver. So DHCP resolver is having this, that the request is in the mode of broadcast. So if it is forwarded, the broadcast requesting is forwarded through Unicast channel, but it is broadcast is, if you see the last point, it is coming as a broadcast request only. Address will be same, means address will, it will take the global, it will take FFFF, but it is redirecting. No, that is basically configured so that other broadcast addresses, other DHCP server should not respond. And all. If you have multiple DHCP server, okay, then we may restrict, or we rather need to restrict, and that's why we specify that. Okay, but I do not know. I have not seen, but there are ways we can send the request in a multicast mode. Means it can go to 3-4 servers also. Anyway, that's a different discussion. So what is happening immediately? It will giving me source IP address. Means it will respond that this will be your source IP address. So it is basically not ARP, it is RARP. All of you know RARP. Okay. So RARP, the request is coming, and this 192.168.0.100 IP address is allocated, and then the packet will change. So the returning, it is unicast. So returning packet is basically unicast. When it comes back, you can see server to client is simply, it is allocating IP address. After allocating IP address, it is broadcast communication. But this verification is, but sir, it is verified once the channel is established. It is verifying only 1-to-1. Okay. So here the source and IP address is defined. So I'm just see source address and IP address is totally defined. Source and IP address is defined anyway. But the entire process is using the the entire process is using the broadcast only. So leave it, no issues. So it is entire process is basically using the broadcast. Okay, it's a broadcast channel. If I talk about the channel, it is a basically broadcast channel. The channel is broadcast, but it is when the packet is replying. I'm telling packet is not replying to many. It is replying from the server to client. Okay, in a unicast mode. I'm not telling it. It's a unicast channel. It's in a unicast mode. You need to understand the difference between channel and mode. That's right. No, it is getting the IP now. I'm offering in the IP. So client is in 0, but after that, when it finally acknowledged, so it is something like this is your request. This is what you are allocating, and the allocation is coming here, and after the acceptance, this is pure unicast that I am only responding. But here this is using broadcast channel. The entire thing is using broadcast channel because the entire system is in broadcast mode, and that is the reason DHCP is not being directly configured in IPv6. Okay, so we are having different, DHCP v6 worked in a different mode, and that is the reason this UI64, that is stateful and stateless. We call it as SLAAC, stateful and stateless automatic address configuration, that is there in IPv6. Anyway, this is my IPv4 configuration where this is my DHCP client. Anyway, the crowd is good, means I am deviating, means someone who is new might be getting distracted because our discussion is going to a different mode. So there are interesting topic of discussion. When the students always ask, they ask on this concept. When the interviewer asks you, they don't ask you this state question, this confusing question. They always ask you, okay, that why you need to have this APIPA. No. Global DHCP server, no, global DHCP, no, global. Which one? It is default routing, but it is a global client, na? It is a local client, but I'll just check and get back to you tomorrow that the term which I've used is right or wrong. I'll just check. Yeah, I'll just check. I'll just check because if I have used any term which is not there, I'll just check. Anyway, so okay, so it's a DHCP client address, but I have to check it is a local or global. I have to just check, means if it is a wrong term use, I have to rectify. Anyway, so 192.192.223, 192.168 is a again a private addresses. Yes, sir. Okay, coming, sir. Okay. So class D is basically used where? Can anyone tell me where class D addresses are used? Routing. For example, if I'm if I'm actually seeing the configuration of REAP, this routing, uh, REAP, OSPF, EIGRP, in all the cases, okay, the routing communication is basically using multicast addresses. So you sorry, REAP version 1 is REAP version 1 is, thank you. REAP version 1 is purely broadcast, and REAP version 2 is okay, multicast. EIGRP has an old version, that is IGRP. IGRP is using broadcast, EIGRP using, okay, multicast. OSPF version 1, which is not there. Okay, OSPF version 1 using broadcast, version 2 use multicast, and version 3 is IPv6. So there are three versions, and EIGRP it is called IPv6, EIGRP for IPv6, and REAP it is called REAP NG, next generation. Okay, so these are the different types of routing protocols where in again BGP and all, there they use multicasting. Why multicasting? For example, in a yes. OSPF version 1 is classful. Version 1 is classful, which is very old model. Then version 2 came, which is a classless, and there it is using multicast. And you hardly get a router which is using OSPF version 1. Version 2 is used, means by default, OSPF come with version 2. You will hardly get any device in the market which has version 1. Version 1, I will rather say that from the initial stage,